our students. And then welcome, welcome. Yep, just remember. Okay, so all of my students that can currently make it appear to be here. What about you, Daniel?
Yeah, same. All my students are here as well.
Okay, let's give it a few minutes for their families and stakeholders to come in, and we will get started. All right. No, I'll say one of the perks of having these bulky headphones means I don't have to worry about my hair as much, especially on a Zoom call.
Does
Granted,
serve
once I
just like
take it
a,
off.
it is
Yeah.
just a headband.
Yep. All right. Mhm. I'm personally very excited for everyone to be able to see what our students have been working on and dedicating themselves to the past 3 weeks for. So, one more minute. Once it's 8:05 for me, I'm in EST. I imagine it would be 5:05 in PST.
We should have about 5 minutes per student.
Okay. Okay, it is now 8:05. Let us start. So, welcome everybody. Glad you all could make it. Glad you're here to be able to bear witness to what a lot of our students have been really passionate and been really focused on for the past 3 weeks. So we do have an itinerary in terms of order of students we're going to go through. So the first student is one of mine. So I will start. So his name is Yash, and his main project was the development of the three-axis robot, a robot that you can control through various means, but main way is using a controller with some joysticks that you put together yourself. I'm really proud of Yash in the way that he was able to take matters in his own hand to try and fix a lot of issues that befell him. Mm. Through his own exploration of the code, he was able to deepen his understanding of his work. And even if some of the past that he tried to remedy didn't really bear fruit, it's a fact that he tried and learned a lot of skills for problem solving that happened. So, Yash, if you could take us away.
Hi guys, I'm Yash and I'm a rising junior. And for my project, I made a three-joint robotic arm. So the first joint is controlled by the first servo and it resembles a shoulder. And the second joint is controlled by the second servo and it's kind of like a elbow. And then the third joint is controlled by the third servo and it's like a wrist. So here's like a quick visual of the project and this is how it rotates. So the basic idea was to move four servo motors that act like joints in the arm for my project. And at first my plan was just to control them with a simple like joystick inputs from a controller. But I wanted to make it more advanced. So I decided to add a software modification. And I used a Python web server using Flask, which locally runs on my computer. And the goal is to create a local web page that can send commands to the Arduino, which is like the brain, and communicates with my computer to move the robot. And basically, the web page sends commands to the Arduino over a USB serial, and it would let me control the arm wirelessly using any device with a browser on the same network. And right now, the server hosts a simple interface with buttons to turn things on or off, and then it sends those commands to the Arduino through the serial connection. The hardest part for this entire project has been getting the USB serial connection to work consistently, which I'm still troubleshooting at the moment. And I've also ran into issues with the COM ports not showing up or like the access being denied, which I'm also still troubleshooting. And although the project isn't 100% finished yet, I'm learning a lot about serial communication, web servers, and integrating hardware with software. And I'm also planning to keep working on fixing the connection so I can have a fully controlled robotic arm in the end. And basically, uh, the structure of the robotic arm is made out of acrylic, and uh, the controller is connected to digital pins from D0 to D3, and the servos are hooked up to wires connecting to analog pins from uh, A through 3. And here's another visual of the project. As you can see, this is the rotating motion of the arm, and this is the front and back motion, and then this is the opening and closing of the claw. Does anyone have any questions?
Just to remind everybody, this is open to anybody. So doesn't matter if it's parents, family, or other students. You're all free to ask questions here.
I have a question. Hey, I'm wondering how strong that gripper is.
It's actually not very strong. Uh, it can pick up like a slip of paper, but like it's not gonna rip your finger off or anything.
Okay. Would it be able to pick up an egg without crushing it?
Yeah, probably.
Cool.
All right. Any other questions? Anything you're curious about the project? Okay, so round of applause. Good job, Yash. Good job. All right. So next up, we have one of Daniel's students. So if you'd like to take us away.
Right. Yeah. Next up, we have Charlotte. Charlotte has been working very hard on his ball tracking robot. So the ball tracking robot is intended to use a camera to track a red ball and kind of input commands to their motors so that it can kind of either track it at a distance or be able to turn towards it. And we've kind of taken that project and gone way leagues ahead of it, adding things like a image recognition pipeline, additionally use importing and soft like a image recognition module as well as a lot of other additions that Charlotte was able to add on his own. So we're really excited to have Charlotte share what his journey has been like and what modification he's added as well. So Charlotte, please go ahead.
Hello, my name is Charlotte. I go to Culver Academies and I am a rising junior. As said before, my base project was a ball tracking robot that can follow the movements of a red ball. Some of my modifications included adding distance sensors to prevent the robot from running into anything, adding a servo mount for the camera so it can track objects moving up and down while remaining stationary. I also added an image recognition that streams a feed from the camera into a browser, then recognizes basic objects and animals that come into frame. I have a video of some of the functions, which I'll share now. Okay. At the moment, everything is functional, and I am hoping to flip the camera upside down so that this ribbon doesn't get stuck on the bottom servo. I I joined Bluestamp to gain confidence and begin to create projects like this on my own. Feel that I've 100% gained this confidence and ended up completing a number of the modifications and parts on my own. I want to study engineering, so when picking, I was looking for a more challenging project. I also love the versatility of the different components and all the modifications that I could make. That's all I have. Any questions?
I have a question. Do you know why the image recognition software is called YOLO?
It stands for something. So the YOLO all have letters or like words associated with it. I don't remember what those words are. Um, yeah,
Fair, fair.
yeah.
I have a question. Does the AI or does the vision processing happen on the device, or do you have to push it to the cloud to be processed in the cloud?
So what happens is for the manual one, it streams a feed from the camera onto my browser. There's a
Mhm.
button that I click to take a picture,
Mm.
and then on that same site, they have a built-in area for data, which is where that initial picture goes. You just hit a button that says process, and that goes to pictures, and those pictures are stored in the same place as my code. For the automatic one, it does a very similar thing, except it automatically takes those pictures and stores it in the same place where I store my code.
Sweet, sweet.
All right, thank you very much, Charlotte. Are there any final questions, or we will move on to our next student? All right. Moving on to our next student, we have another student of mine, Rachel. So for her project, we have a third eye for the blind. So the premise of this project is to use ultrasonic sensors as a way to kind of give vision for people that are blind. Obviously, they can't see, so they need some way to detect how far things are away from them. So this is a very like a humane kind of device that you can use to help people with disabilities. So we struggled with a lot of technical issues initially, things like ID incompatibility and said breadboards. But I'm very proud of Rachel to be able to navigate all these things and be able to learn a lot of things such as breadboarding, multimeter usage, programming in Arduino, and sensor interfacing. So without further ado, we'll have Rachel show us software project.
Hi, I'm Rachel. I go to Lee High School and I'm an incoming sophomore. Uh, uh, my project is Third Eye for the Blind, and it uses an ultrasonic sensor and it has an Arduino code that uses ultrasonic sensor to measure how far away an object is, and it sends out a sound wave from the trigger pin and waits for it to bounce back and measures how long it takes to return using the echo pin. Then the code calculates the distance based on the time it took, and if the object is closer than a set distance, then the buzzer will turn on and make a sound. And if an object is farther away, then the buzzer will stay off. This is what it looks like, and there's also an LED, and that turns on when the buzzer is on. Uh, yeah. I chose to do Bluestamp because I don't have any experience with anything engineering related. I've never coded before or done any robotics. And the reason why I chose this project was because out of all of the beginner projects, it seemed to have the most physical components. And I really like building things and being able to use my hands. So it drove me to choose that. Uh, um, any questions?
I'll ask. So if you had the chance to add more modifications to the project, what do you think you would do?
Um, I'm using a Nano ESP32 right now, and I know it has like Bluetooth and Wi-Fi connected to it. So if I could add in more modifications, maybe I'd like connect it to an app or a website or something so it could monitor the data like automatically and you can like check on it. Yeah.
Um, for what distance does the light turn on?
Well, currently right now it is 10, but you could set it to be farther.
Okay, if nobody else has a question, I have one. What do you think was the hardest part of doing your project right now? What do you think you learned the most from?
Definitely like the breadboard and the circuiting and everything, because there seemed to be a lot of technical difficulties along the way. Um, yeah, that was definitely the hardest part.
So, are there any more questions? Okay, if not, we'll have Lee introduce our next student.
Okay, as for our next student, his name is Soham. His name is Soham, and he also worked on the three-axis robot as well, and managed to add his own unique modification and twist, though due to some technical difficulties, while it wasn't the one he was hoping to get, he was able to perform another modification, even given limited time. And I'm very proud of his ability to engage with the project, even with his ability, and using that to make something that he's at the very least invested in and hopefully somewhat proud of. Something he can appreciate. So, if you could take us from here, Soham.
Hi, my name's Soham. I'm a rising eighth grader at Wissahickon Middle School. Um, this is the project I made, the three joint robotic arm. I'm waiting on a replacement finger currently, but that's gonna come with time. I have a video demonstrating the project, which I can share with you all. So here we go. Um, so yeah, here's the video. I can control the claw by moving one joystick up. It still has some code issues, which is why it's moving like that. But I can control that bottom servo as well with the other joystick. And also, when I move the left joystick up, it turns the yellow LED on. When I move it to the right, it turns the red one. And when I move the right joystick up, it turns the blue one on. So currently, I can't display it right now, like in person as the code isn't working, but I was able to record this earlier today. Um, how the project basically works is that there are servos wired into this, which connect to the nano shield, which is kind of like the center of everything. Everything's plugged into here. It's controlled with this controller that is also wired into the nano shield. And the other thing in there is the Arduino Nano that I have. This holds all the code and tells everything what to do. It's it allows me to control how this moves and make these LEDs light up with the code. The most challenging part of this project was definitely debugging the code, which I'm still working on. Sometimes it still moves around randomly, but that's an issue I think we can fix eventually. From Bluestamp, I learned that engineering is sometimes just like trying something on your project without like a specific reason behind it and just seeing if it works or not and just repeating that, even if there's like not a focused attempt on fixing something. That's how I resolve some of my issues. I joined Bluestamp so that I could learn more about mechanical engineering, which is my passion, and also learn more about the engineering experience as a whole. For the future of this project, I'm thinking of adding Bluetooth to it, which is my original modification, but due to time and some part conditions, I wasn't able to do that, which is why I went to the LED modification. But that could definitely be a future goal for this project. I picked this project specifically because I thought it was a nice blend of mechanical engineering as well as robotics, which are two subjects I'm interested in and want to pursue further. Does anyone have any questions?
Anyone have any curiosities?
What code is the servo in?
It's an Arduino IDE, so C++.
Trying to say. So what was your biggest like lesson you learned out of Bluestamp? I'm just curious.
Um, Definitely to just like not give up and keep looking for a fix. I think that was kind of the core of my whole project, just looking for a fix somewhere and not abandoning it totally. So just having that persistence.
Okay. So, does anyone have any other question before we move on to the next student? No? Okay. Good job, Soham. Good job, Soham. Yeah. So for our next student, he goes by the name Jason. And what he worked on is a ball tracking robot. A robot that's able to use computer vision techniques to be able to locate a ball in space and then use the robotic platform it's built upon to navigate them. But he managed to add his own twist of things by adding a solenoid valve to be able to push the ball, give it a little punch or a little kick. So I'm proud of Jason. One of the things he managed to exhibit over these past few weeks is his ability to reliably work and develop his project. Keeping a slow and steady pace is, I find, somewhat an undervalued trait within today's society. So the fact that he was able to exhibit that, I think it's very phenomenal. So, Jason, if you're able to take us away.
Yeah, like Mr. Nestor said, my name is Jason M. I go to Lowell High School and I'm a rising sophomore. So I did the ball tracking robot. It's pretty self-explanatory. It's a robot that tracks a big red ball. So it's coded through VS Code and Python and powered by the Raspberry Pi. I'm gonna give a brief demonstration of it right here. Okay, so and then I also have a modification, like Mr. Nestor said. It shoots, or it basically shoots it because the solenoid's electromagnetic and it uses a spring to do that. So I'm gonna run the file again. Is it in sight? You see it
Not at the moment. I have to be a little bit lower.
like that?
Uh,
Just a
hair
bit
lower.
more.
Okay, good. Yep.
Alright. So okay. So once it like gets close, it'll click and then it'll shoot it out.
Yep.
Mixed up my code. Okay, so basically it all starts with the base plate, and I added motors and wheels and a little turning wheel to help with steering. So it's wired by the breadboard to the Raspberry Pi to get powered, to get the motors powered because we had no female to female wires at that point, so we use male to male. So for the visual part, it uses sonars and the Raspberry Pi camera to help see the sonars track the distance, and the Raspberry Pi camera tracks the ball using contours, which are a line that outlines objects of the same color. So like I said, I used a linear actuator and a relay module. So the linear actuator is electromagnetic, so it uses spring to propel itself. And then the relay module allows me to control when to use the linear actuator by opening and closing circuits. So my biggest trouble was today I was trying to fix a motor because it moved too slow. And it was like the friction of the table slowed it down even more. So I broke a part of the base plate by doing that. So this taught me to keep calm and like work on the things I could work on and breathe through the problems I chose this project because I'm in my school's robotics team and I wanted to develop my skills and learn the basics in like Raspberry Pi, wiring, etc. to help my team next year. Thank you.
All
Is there any
right.
questions?
How far does it like push the ball?
Oh, it doesn't really push the ball because it's kind of weak and small. So it shoots at it.
So a question. Could you walk us a bit through or in more depth about the image tracking or how you're detecting the ball, the
Um,
process for that?
so basically on the code opens up a website and then the website shows um, the tracking of the ball. And like I said, through contours. So the ball is like really one big red ball. So it's an easy thing to track.
Did you use Flask to like as your for your website?
Flask? I'm not quite sure about that. Sorry.
Does anybody have any other questions? Okay. So, wonderful work, Jason. Wonderful work. All right. So, next up on the block is another student whose name is Ethan. And his project is using imbuing machine learning in an embedded device and using it to recognize gestures, but not only that, output those gestures as emojis. And something I appreciate about Ethan and how he approached this project is he was able to use a lot of skills and understanding and knowledge he had before coming into this program to be able to interface with the project. And then with his interfacing of the project and development, he furthered those skills even more in realms they wasn't familiar with, such as C++ or machine learning. So, with that being said, Ethan?
Yeah. Hi guys, my name is Ethan and I'm a sophomore at Homestead High in Cupertino, California. My project was a gesture detector using the machine learning library TensorFlow Lite that detects your gesture using an Arduino microcontroller, which looks like this, by the way. I don't know if you can see it. And then it makes an assumption of which gesture it is based off the training data. Afterwards, it outputs the gesture using emojis. So for my project, all I needed was a USB cable, an Arduino microcontroller, and my computer. And this project was a lot more software based than hardware. And then first, I had to gather the data by exercising the gesture and then collecting it through a CSV file via an Arduino microcontroller. Afterward, I trained a model using the data through Google Colab, which is a digital notebook used to run code through cells. Lastly, I had to upload the trained model file onto the Arduino IDE to make it work. And then in the following video, I do want to point out that my arm got cut out of the video, so you can't see me performing the gestures, but here's my video. Okay. Quick demonstration of my project. Yeah. Yeah, so I'm just plugging in my USB cable to my computer, and then I have to connect it, connect my microcontroller to my computer, and then as you can see here, I'm performing a punch gesture, and then yeah, it prints out a punch in the console, and then I do another one, which is the mewing emoji over there. Then I do another one, which I believe was wave. Yeah, and that's pretty much it. And then one aspect that was hard was properly trying to upload my training files into Google Colab, since it always resulted in an error. And another issue I ran into was the tfly error reporter file not in the correct directory whenever I tried to upload my code. And one last issue was trying to make the gestures more accurate, which is something I'm still trying to troubleshoot with, since it takes hundreds of data to make it accurate. And overall, I joined Bluestamp because I wanted to learn how to combine software and hardware to get familiar with electrical engineering, specifically with machine learning because that was a topic that always interested me. And overall, I learned how to use Arduino for the first time. I also got a better understanding of machine learning and how it works, specifically learning how to train a model. Yeah, thank you.
Okay, so does anybody have any questions? It's a fascinating topic, I feel.
Yeah, I've got a question. So you talked a bit about training the model, and some errors. What's stopping you from just doing instead of 100 pieces, 1,000? Is it just the time, or are there other limitations involved?
Basically, like in order to gather the data, you have to copy and paste it manually by sections, and it takes around 10 minutes to capture data that you captured 10 times. So if you do it like 100 times, it's gonna take an hour or so. So yeah.
Yeah, so probably not a great use of time for a 3-week program. Got it.
Have you thought about ways to like increase the size of your data by by creating slight modifications to the existing data, essentially?
Yeah, so originally it was just the punch and flex emoji, but then I added two more, which was the waving one and the mewing one.
All right. So before we head on to the next student, does anyone have any other questions? All right. Good work, Ethan. Good work. Next up is a student. His name is Karthik, and he worked on the 3-axis robot. But he added his own spin to it. Pun intended, he added some motorization to it. While not completely attached to the platform, he was able to get some of the motorization working and developed in time for this demo. And with Karthik, I'm really happy with his ability to ask questions to further his understanding. You know, a lot of people understand there's a little power in a statement, but there's also a lot of power in asking questions. And that can lead to a lot of positive results. So I hope he maintains that into the future. So, Karthik, is ready to go?
So my name is Karthik. I'm going to be at Capella High School. I'm going to be a sophomore next year. And so basically my project is a 3-joint robotic arm. And so using the code, which is in C, um the using the joysticks, the Arduino like figures out the directions the joysticks move to correspondingly move the servos. And so here is my demo. So that was the demo. And a challenge that I went through was actually coding because like I've never coded C before. So like learning that in like 3 weeks, like less than that was a little challenging. And some learning or experiences that I learned was that what each part does. Because thanks to Mr. Nestor, like I wasn't really sure about Arduinos and sensor shields, what they do in motor drives. Because I've never like actually interacted with them before. So thanks to him, I was able to learn the basics pretty quickly and actually like start my modification, which is like being for it to be able to move on wheels. And I chose Bluestamp because in the beginning I was supposed to just like sit around do nothing in summer break, but I was like I don't want to do that. I want to be able to learn something while actually having fun and doing something hands-on. So that's why I joined BSD. And yeah, that's my product. Any questions?
Does anybody have any questions before we move on to the next student?
So what is your goal with your modification? Just to get it moving so you can pick up
Yeah,
things?
because it's a little annoying to like have to pick up the robot and like move it around. So I want to be able to like put it on wheels, make it be able to like move places. And like if it's in a tight spot but it's like far away, it can like move to the tight spot and like pick it up. So yeah.
All right. So, any more questions before we move on to our next student? All right. Give it up for Karthik. Yeah. Whew. Great work. So, our next student, her name is Anjani, and she worked on this ball tracking robot. And like many of my students, in fact, all my students, she managed to add her own unique twist of things. Not only does it track the ball both with the robot itself, but also with the camera as well. So one thing I really appreciate about her is her capability to maintain a solid and steady pace, even in the face of various problems arising, whether it be technical difficulties with malfunctioning hardware or whatever software nightmares come about. She's usually there and usually putting in the time, which is very important. So, Anjani, if you would like to take us away.
Hi, my name is Anjani. I go to Vista del Lago High School and I am a rising junior. And the project that I've been working on is the ball tracking robot, which, like its name, is a robot that will track and follow around a red ball. Let me show you how it works. So that might have been a bit hard to see as it was so far away. But here, sorry. But here, you can see that as the ball moves, the camera is able to turn because it's on a servo, which is just one of the main parts of my robot. So you have the servo, which is able to turn the camera, which is the thing that's able to detect the ball, the sonar sensors, which are able to detect the distance of any objects that come near the robot, and the Raspberry Pi, which is able to tell what all the other components what to do, and the motors, which are able to move the robot. One thing that I've had many challenges throughout this entire process, but my most recent one that I've encountered is the fact that in order to make the robot be able to move to the same degree as the servo, I had to figure out how long the robot has to turn either left or right to match the turn of the servo. I was able to figure this out through multiple trial and error, but in the end, I was eventually able to get it. Um, Through this project and Bluestamp, I was able to learn both technical and practical skills. I wanted to increase my technical skills because I'm in a robotics team and I want to be able to um, help our team learn more about coding and robotics in general. So through this project, I've learned technical things like learning more about how cameras and how the sonar sensors work and how they can be coded. And one of the more practical things that I've learned that could be used for in general is to keep trying even if things don't seem to be going your way. And that's it. Any questions?
I have a question. How hard would it be to make it so that it would play the Jaws theme song as it's chasing the little balloon? That'd be awesome.
That would be really cool. Hmm. I I would need to get a speaker in order for that to be able to work, but that's a good idea. I might implement that.
Yeah, you should try it. It'd be cool.
How is, oh, sorry, you go.
All right, okay. What is the function of your sonars?
Hmm?
Sorry, I'll say it again. What is the function of your sonars on your robot?
So the sonar sensors are used in order to detect if the ball is in front of it or not, so that it'll be able to stop moving if it's like too close.
How is your camera connected to the servo? I just noticed it was a different one than I had used, but I'm curious.
I'm gonna be completely honest with you. I kind of just taped it around the servo horn. So it's not properly attached, but it's working, so yeah.
Okay, so does anybody have any other questions before we move on to the next student? If not, all right. Good work, Anjani. Good work. All right, so the next student up is one of Daniel's. So, Daniel, if you'd like to take the next part.
Yeah. So next up we have Leandra. Leandra's project was to create a biometric tracking, but biometric monitor and display. So she worked with a lot of the like using an Arduino, worked with a lot of sensors and having them integrate the data and then process them to send them onto an LCD display. We ran into some technical challenges, especially when it came to dealing with the wires and having to learn how to wire a circuitry properly. But I'm really, really proud of the way that Leandra handled all of this and was able to effectively follow directions and also kind of put in her own efforts to be able to uh, learn all these things in a very, very short amount of time, especially without any prior programming or wire circuitry experience. So I'm really proud of the journey that Leandra has been on. So without further ado, we'll have Leandra share her project with us.
Hi, my name is Leandra. I go to Kip College Prep and I'm a rising sophomore. My project, as was said, my base project, as was said, is a biometric monitor and display. The components of this project is mostly in my Arduino Uno, a breadboard, LCD screens, and multiple jumper wires, and the pulse sensor. This is my project. Some challenges that I went through while with my project, it was definitely wiring and coding, specifically because like it's the first time I've ever done it. So also while doing it, I was learning and having to input the work that I learned. So that was very difficult. But yeah, the reason why I joined Bluestamp was because I wanted to get out of my comfort zone and be able to just see a different field because before this program, I've always been interested in like medical things and like that type of field. But I wanted to like get out of my comfort zone and see a different field. And I can definitely say that after this program, I'm definitely wanting to look more into engineering and just want to get to know the field better because I found out that it's something I'm very interested in and it's something just very fun to do. Any questions?
Yeah, could you share a bit more about your modification, what you added to your display?
For my modification, I decided to add a temperature sensor so I'm able to see like the temperature along with the heartbeat at the same time. They both show up together in the LCD screen. Any other questions?
I also have a question. So your project has a lot to it. It's got a little mechanical, it's got a little electrical, it's got a fair bit of coding. Is there one particular branch that you felt like you were being drawn to most, or did you like them all? What kinds of things did you discover about your own preferences on things you like to work on?
Okay, so definitely, even though this is like the branch that I had the most trouble with, I think I was really pulled towards coding. I find it to be very fun to like have to like figure out the little things from it and see what works and what doesn't. even though that was like one of the most challenging things, it was definitely fun to like see what works on a project and what makes it work and what doesn't.
Awesome. Awesome.
Are there any more questions? All right, if not, we'll have Lee introduce our next student.
All right, so our next student, he goes by name Noah, and his robot or his project is the ball falling robot, but you may not recognize it as so because he has added a lot of very fascinating customizations. So yes, it does follow the ball, but it also grabs the ball and many other things that he was more excited to show you. Something I'm proud of Noah or with Noah is his dedication and passion to this project, something he cares deeply about. That's a very important flame that I hope get nurtured in upcoming years. And I'm pretty confident that through his passion, he managed to inspire other people in his class. You know, everyone when he showed everyone his like robot, and it's like, wow. So, Noah, if you could take us away. Remember, 3 minutes.
Hello everyone. My name is Noah, and I go to Gretchen Whitney High School, and I'm a rising senior. So the robot I have right here, I gave it a name. It's called the Catmobile. Well, originally my intention was to make it look like a Batmobile, but I decided to add like a cat spin-off. So I'll give you a quick demonstration of the project. Let me pivot to my phone. Give me a sec. All right, hello everyone. Okay. So you're probably wondering why it's dark in my room. Um, oh boy, I am muted.
You're good. We can hear you on the
It
phone.
seems I'm
We can hear you,
muted
Noah.
on my phone. Oh, that's not good. All right, so you're probably wondering why it's dark in my room. So right here, I have a flashlight. I'm gonna use my camera from my phone instead. Sorry about that. So this here is a flashlight, a really tiny flashlight. And there's a hole right here where I can put my flashlight. And basically what this robot is able to do is able to track the ball, drive towards it, and use its claw function in order to just wrap around the ball. So as you can see here, the robot's in place. And when I start up my code, it should give it a second. It should, and now that it's working, it looks around for the ball and it dives towards it. It adjusts properly, and then when it's there, it closes. And I can move the ball, and it's just gonna work entirely autonomous. So I'll pivot over back to my computer. Let me turn the code off. And yeah, so that is a ball tracking robot. What it's able to do, aside from just grabbing the ball, is able to have a live stream, so you can really just see like what the um ball sees. I mean, what the robot sees. So some of the electrical components of it. First off, we have the servos on the outside, and that allow the claw to work, and then the sonars, and then we have the Pi camera and the motors. So then on the inside, I have the detachable lid here. So we basically have our Raspberry Pi, that's sort of the brain of everything. We have our motor driver, our breadboard, and the power bank. So some of the other things I added on was the shell that I 3D modeled and printed, the claw, as well as the flashlight. So the code I used was through VS Code, and that basically connected my Raspberry Pi to my computer, and I was able to send code to the Raspberry Pi. One challenging aspect I had was having the robot center the ball so that I could pick it up in the right spot. So the solution I found was implementing something called PWM signals. So that's basically a technique to control the average power sent to my motors. So for example, it'd be sending voltage like high, low at a rapid pace, and it pretty much works based off the percentage that it is on. So you can control like it's on 30% of the time, for example. So what I did was I made really, really tiny like modifications to the driving function so it could turn and it wouldn't overshoot. So it could have more like smoother turns. So one lesson I have from this entire program is that not everything works for the first time, and it's how you move forward from it. So some of the technical takeaways was definitely learning how Raspberry Pi works and like deepening my knowledge on Python. So the reason why I joined this program was because I wanted to learn what it's like being an electrical and computer engineer. to like better prepare myself for college. And I chose this project because I've 3D modeled cars before and I just wanted to bring life to this one. So that's it. Thank you.
All right. So, does anybody have any questions? I have a question. What did you use to model the what did you use to model the shell in?
Yeah, I use this browser or CAD software called Onshape. Yeah.
Mhm. All right. Does anybody have any other questions? All right. So, round of applause, great work, great work. So, our last student unfortunately could not make it. So, yeah, our last student could not fortunately make it. So, his name is Taka, and what he worked on. Well, first I'm going to go over what he did, his name, and everything, and then we're going to have the video that he put together in his absence. So, his name is Taka, and he worked on the ball tracking robot as well. And I like to think that every student managed to place a bit of their own personality into their work. A famous comic book creator once said that a bit of ourselves goes into everything we make. And I like to believe that he put something he was interested in. He was very fascinated with machine learning. So for his modification, he made his robot voice controlled by setting up a recognition model using a local form of OpenAI's Whisper. He's able to command it, interface with it through his voice. So, if you could play the video.
Hi everybody, sorry I couldn't be here for demo night today. I had some other commitments that I had to be at, but nevertheless, just wanted to give a quick demo of my project. But hi, my name is Tatva. I go to Westview High School down here in San Diego, California, and I am going to be a senior next year. The project that I chose was the ball tracking robot, and I will give you guys a quick demo of this real quick. Sorry, let me just set something up. Forward, left.
Yeah. So the technology is very fascinating, running a local model on a Raspberry Pi. So he's able to auditorily direct it to where the ball is. So I'm very proud of the care that he's able to demonstrate for his work and his innate desire to make something that he is proud of. That's an important aspect for a lot of people to care about stuff. As simple as that sounds, being able to care about stuff, very important, very helpful. So currently he's unable to not be here because he has an internship and entrepreneurial orientated business. Unfortunately, I don't have the best business mind, so I couldn't really grasp a lot of details. But he's very motivated, and I think it's very wonderful. So, does anybody have any questions that hopefully I can maybe answer in instead? Yeah. All right. Any questions? All right, sick. So let's give a round of applause for all the students that really put a lot of effort into their work today and was able to come up here and show us. It's a difficult thing to do, to put a lot of yourself into something over the course of 3 weeks and then be able to present to other people. Engineers aren't exactly known for their public speech skills, but in spite of that, a lot of our students came out here and I think did very good. So, all right. So with that being done, that should be everybody. So yeah, thank you all for coming
Hey, a
tonight.
quick word. I think they're still running room 2. If you want to catch a couple extra presentations, feel free to bounce over there and see some of what our other students are doing. I just want to thank all of our students, all of our parents, all of our staff. Everybody's done a spectacular job. Have you seen with these projects? I'm so proud of all of you, and I want to encourage you. Tomorrow is the last day. Finish strong, earn your holiday. Get all of your deliverables done with the website and the documentation, and you'll feel awesome come this weekend. Congratulations, and thank you all so much.
Yeah, you guys did wonderful. Oof. Yeah. Yeah. Okay.